let's start with data binding. So what is data binding? Data binding means you bind data from a data source to a data consumer. In Android, this usually means you bind data from the local storage or the network to the layout. Another important feature of data binding is that data changes are automatically synchronized between the layout and storage. So what are the benefits actually? I mean, we've all written this kind of code. You know this find view by IDs, all those setters and listeners and all this kind of stuff. Even with Butterknife, it does not really get better. So data binding is here to save us from all this stuff. A binding class is generated on compile time for you, and it provides all the views which you have IDs defined as fields on the binding object. Actually, it's also faster than find view by ID, because it only traverses the view hierarchy once. Also, the binding class implements the binding logic, so you don't have to call all those setters and whatsoever anymore, because you don't have to. The binding class does all the code for you. So yeah, that's actually pretty nice. So let's get started. The first thing you need to do to set this up is go to your build.gradle file and add data binding enabled true. This tells the build system that it should start processing your layout files and generate bindings for it. So now in your layout files, you just wrap your topmost element in a layout tag. This tells again the build system that it should generate a binding for this layout. Also the namespace declarations move into the layout tag. The next thing you do is you declare the data which you want to bind in your layout. You declare variables by name and type, and what you can also do is you can import other classes, so you can use, for example, constants or static methods. Now the final step, which is maybe the most important, how you can actually bind now data. So as you can see, data binding instructions start with an @ sign and are enclosed by brackets. So in these expressions, you can use all the variables which you defined in the data section. And actually, nearly everything which you could do in code is supported here. So for example, string concatenation and everything. And as you can see with the visibility attribute, there's also a ternary if-then-else operator. Or with the text attribute, there's a null coalescing operator, which chooses the right operand if the left one was null. Also, resource access happens just like with how you normally do it in layouts. You can see this with the padding, where I choose different dimensions based on whether a Boolean value is true or false. So now properties of your variables are accessed via the field access syntax. You can see this with viewModel.text here down there. Basically what this does, it calls the getText method of your viewModel. So you just use field access syntax and you don't have to write like getText here. Finally, some small restrictions apply. For example, you cannot create any new objects here. But yeah, data binding is still pretty powerful. So now that we know how data binding basically works, we need to know what attributes we can bind to. So most of the standard attributes of the views in Android are already supported. What happens internally here is that the data binding library looks for a setter on the view with the attribute name where the binding is used. So for example, if you bind to the text attribute, what happens internally is that the data binding library looks for a setText method on the view with the corresponding type. So if your text property is a string, it looks for a setText method with string as a parameter. So basically what this means is that you can also use setters which you normally wouldn't be able to use in the layout. As you can see, you can, for example, directly bind the adapter to a recycler view, because what happens here is it just looks for a setAdapter method on your recycler view, and it just works. What you have to keep in mind here is that not every standard attribute has a setter in the view. For example, padding left, there is no setPaddingLeft method. But the data binding library provides custom setters for some of these cases. For example, with padding left, it just works. So what do we do if there is no custom setter provided by the data binding library? For example, if you want to bind to layout margin bottom. For this use cases, you can write custom setters yourself. To do this, just use the binding adapter annotation and provide the attribute you want this binding adapter to be called. As you can see here, this is a binding adapter for layout margin bottom. Now for the implementation, the method just has to be public static void, and as parameters, it first takes the view with your view type. For example, here it's possible to, the binding adapter can be called for all view types. And as a second parameter, you pass in the type for which the binding can be called. So here, for layout margin bottom, we pass in an integer because we want an integer dimension here for layout margin. So all in all, finally, you just implement the method. So again, as you can see here, this is a binding adapter for layout margin bottom, which works for views and binds an integer value. It's also possible to bind multiple attributes. For example, this can be handy if you want to do image loading with data binding. I always like to have a binding adapter for an image URL and a placeholder, so I just can define those two things in the layout and it just works. Here again, two parameters are passed in the method. So for the image URL attribute, we have a string type, and for the placeholder, we have an integer type with the drawable ID. And then you can just implement the method however you like. I, for example, used Picasso, but there's any approach possible. So now that we know how to do bindings in XML files and how to use custom setters, we need to know how to actually apply the binding in code. So basically, the data binding library does all the hard work for you and generates the binding classes. What you have to do is get those bindings. For this, you can just use the data binding util class and call setContentView for activities, inflate for fragments, or just bind for view holders. As I already told you, and as you can see here, all the views with an ID are just fields on the binding object, so you can directly access them. Also here, you can set the declared variables in your layout files. So as we have done before, we declared a ViewModel variable in our layout. Here is the place where we set the object for this variable. So we would call binding.setViewModel and pass in our ViewModel here. Another big benefit of data binding is that it enables auto-updating of your layouts. However, you still need to somehow notify the data binding library that your data has changed. For this to work, the variables you set on your layout need to implement the observable interface. And don't confuse this with RxJava, it's another kind of interface. So it's the observable of the data binding library. For simple data types, you can just use the types that are provided by the data binding library, for example, observable Boolean. For more complex situations, like as you can see here, with our view models, you can extend base observable, which provides handy methods to notify the layout of changes. So let's go through this small example. Here we have a view model for, I don't know, a small kind of view. And what we want to do when the whole model of the view changes, for example, if you have a view holder and you scroll through and the whole model of the view changes. So you need to change the whole layout, which is done here in setModel. So if you want the whole layout to change, you just call notify change. This causes the data binding library to rebind all the properties. However, if you look at setAmount here, we only change one property, the amount property. And we do not want the data binding library to rebind all the layout attributes, because that would not make sense if we only change one property. to achieve this, you just have to annotate the property getter with the bindable attribute, as you can see here with getAmount. Then the data binding library creates a field in the BR class, which you can see here. And then you just pass in this BR field in notify property change. Then the data binding library just updates those parts in the layout which depend on this concrete property, which is actually pretty handy because you save processing time by not updating the whole layout. So that was an introduction to data binding. The short summary: first, declare the variables in the layout files and use them to bind to attributes in your layout. Then create the binding in code and set the variables. Finally, make sure that your variables implement the observable interface, for example by extending the base observable class, so that all the data changes are automatically synchronized when something changes. So now let's talk about Model-View-ViewModel architecture. First, let's look into how the three components work together. As you know, the view is the user interface, the layout. In Android, that usually is your activity or fragment and so on. The model is our business logic layer. It provides methods for data interaction and so on. Now, the view model is the middleman between the view and the model. It exposes data from the model via properties, so you can bind to it in the layout. It also contains your UI state, and it defines commands, for example, for click events. So click events can be directly handled in the view model. And most important, of course, that's the presentation logic layer. So all your presentation logic now goes into the view model. View and view model mainly interact through data binding. So ideally, the view and the view model should not know about each other because the data binding is kind of the glue between the two and handles all the stuff. But in Android, they cannot really be independent because first you have lifecycle. You somehow need to tell your view model that the view is created or destroyed. And second, you also have state saving and restoring. And as we know, state is now in the view model. So they cannot really be independent. So they need a mechanism of communication. For this, you define an interface for both the view and the view model and just use this interface for communication. Now, as for the communication between view model and model, they just interact for all data access things. So, for example, the view model can update things from the model layer or fetches data from the model layer. Ideally, the model layer should also notify the view model if changes happen, but that can depend on your concrete implementation. Generally speaking, the separation of the view and the view model makes your presentation logic easily testable because you now have a separate component just handling your presentation logic. So together with data binding, this means less code, cleaner code, and yeah, better testability. So let's look at a more advanced example here. On the left side, you see a view model, and on the right side, you see a layout. So basically what we do here, first we set the variable as a variable of view model so that we can bind to properties of the view model. On the right side you see we have one variable with our view model with the type of our concrete view model. This enables us to bind in the layout properties of our view model. What we want to do here is we have a text property in the view model and we want to bind with it on the edit text. Actually, what we want to do here is two-way data binding, so that inputs from the user is automatically saved back to a view model. So basically, that's a text watcher if you would do it yourself. So to enable this, in your view model, you have a getText method for getting the string and setting it onto the layout, and a setText method which sets changes back to your view model. And on the layout, you just bind it. As you can see in the edit text with the text attribute, just say add and now the equal sign for two-way data binding, and then just bind the text property. Another example here is the Boolean for should show text. So, for example, you can define a Boolean whether something should be visible or not, and then you just bind to the Boolean property. However, for this to work, we need a custom binding adapter. If you remember, you can write custom binding adapters for all the types which are not supported by the library. So you just write the binding adapter for a Boolean property to set visibility to view visible or view gone, in this case. Finally, if you want to handle events like button clicks, as you can see with the button on the right side, you just create a command in the view model. Here I created an onButtonClick command, and then you just pass in the method reference to the onClick attribute in your view layout. As you can see on the right in onClick. Then just the onButtonClick gets called when you click the button. So actually that's all quite easy. What you have to remember here is just put the presentation logic in your view model. And don't put any logic in your layout. As you have seen before, you could put any code in the layout because the data binding library is actually quite powerful. You could do all kind of if then else stuff and other stuff in your layout. But you should not do that because this makes it untestable. So remember, all the presentation logic belongs to your view model so that it is testable. So do everything in your getters and setters and so on. Now for the setup, I mean, you somehow, as I already mentioned, need to handle lifecycle and state saving. For this, I recommend to create a base view model for all your view models. As you know, in Android, lifecycle handling happens in the activities and fragments and so on. So you somehow need to relay the lifecycle events to your view model. I would suggest you only create 2 callbacks for when the view is created and destroyed, because usually you don't need more. So for this, for example, I created an attach view and a detach view method in the view model, the base view model. These 2 are then called, for example, attach view in an onCreate on the activity and detach view in onDestroy. What's also important here is that you pass in the view interface to attach view, so you can call commands back to the view. Remember, that's the thing with communication between view and view model. Both of these implement interfaces so they can communicate with each other via commands. What you can also see here is that the saved instance state is directly passed into attach view, and then restoring the state can directly be handled in the view model. You can also have to call the onSave instance state in your activity then. But basically, with these methods you're all set up. You just then need to call attach view, detach view, and onSave instance state in your activity and fragment, and everything is handled on the view model side at least. So now let's look at the view side. Here you see an example for an activity. Here too, I recommend that you create base classes, because then you can do all the lifecycle stuff and everything already in the base class, and your concrete activities and so on just have, like, in most cases, 5 lines of code, because the data binding library and the view model handles all the rest. So actually what we do here first, the view model should already be available in your base class. For example, I do this via dependency injection, but you could also just create a new instance if you don't use dependency injection, but actually you should use dependency injection. The second thing is, now you write the custom setContentView method. For activities, as you know, normally you call setContentView to set the content view. What you do now is you just write your own implementation that handles all the setup for your architecture stuff. So first what we do is we call the data binding util setContentView method which sets the content view and creates the binding object for us. The second thing we do, we set the view model on our binding so that we can use the view model in our binding and bind to it. The third thing we do, we call the callback we just talked about, attach view. And we pass in this because this is the view interface. And of course the saved instance state. The other two callbacks can also be handled in the base view class. For example, onSave instance state can be passed on to the view model so it can save all the stuff. And in onDestroy, of course, we just call detach view. So actually that's all you need. With these base classes set up, you can start implementing Model-View-ViewModel architecture in your apps. While this is a decent base for your apps, there are a few things you need to consider. I will not go into too much detail because that would be too long for the talk. First, as I already mentioned, you should be using dependency injection. I recommend a DI framework like Dagger 2 to inject components. You can use this quite extensively. For example, here I have some component I created for, I don't know, handling some stuff, for example, validation or something. And then I just inject it into my view model. The benefit here is the view model does not care where the components come from. So they just use the components and don't have to handle the creation of all the stuff. That's basically what dependency injection is good for. So it's basically the glue that connects the components. Also, it cleans up your code, and of course, it increases testability because it decouples your code further. This is also great for maintenance because you can just exchange the component if you later need some other implementation. Of course, for this to work, you need to work with interfaces. As you can see on the right, it implements an interface, and I actually inject the interface here. Now a short remark about business logic. Remember, view models should only deal with presentation logic, so don't put any business logic in your view models. An example would be to create repositories for all your model classes. On the left side you can see one for local storage, and on the right side you can see an example with retrofit for network access. So yeah, basically you then just have your repository and access your data through the repository. So please never directly write any data stuff in your view models. Do this in the business logic layer. If you just have basic operations like seen here with find and save and delete, you can just inject those repositories directly into the view model. However, most of the time you have more complex use cases like with validation and so on. In this case, just create a component that sits in the middle between your view model and your repositories and handles all the stuff. Then inject this component, for example, for validation. What's also very important in Android is how you do navigation. I mean, you all know we need some kind of context for starting activities or a fragment manager for replacing fragments. But this stuff always happens in the view, in the activity and fragment, right? So you somehow need a method to do this stuff in the view model. I mean, what you could do is have commands in your view interface and just call these commands. But this brings additional complexity into your whole architecture. So I suggest you create a separate navigator component which provides all the basic stuff like finish, start activity, replace fragments, and create implementations for activities, fragments, view holders. Then you just can inject those implementations in your view model and use the navigator. Then you can do navigation there and don't care about whether it's a fragment or whether it's an activity. So the view model, as you know, should not care what the view is. And with this, you abstract away navigation. So finally, you see a test example. As I already said, now you have the presentation logic in your view model. And as you have a separate component for all your presentation logic, it is really easily testable. So I always prefer Mockito to mock the view interface and other components that are injected, for example, repositories or navigators. Then on the setup method, you just initialize your mocked objects and create the view model, the object under test. Here it's important to put in the mock objects. Finally, you just call attach view and pass in your mocked view interface. So basically then your tests are set up and you can start writing tests. Tests work the same everywhere. First you define behavior, then you call the method under test, and then you verify it or make assertions. Here is an example for a button click. It should submit the form and save the model. So what we do first we return, we say when create is called on model repository, we return a new model. Then we call the method under test, which is on button click. Finally, we verify that it really is saved and that the navigator is called to finish the activity. So basically, as you can see, it's really easy to unit test your view models and your presentation layer like this. So that was an overview of how you can structure your app with Model-View-ViewModel architecture and with the data binding library. To summarize it, again, the view model is the middleman between the view and the model. The view is automatically updated with the properties of the view model via data binding. Commands in the view model are called on view events, for example, clicks. The view model can also call commands of the view if necessary, for example, for state saving and stuff. Also in Android, the view model can handle basic state saving stuff because, as we know now, all the state is in the view model. So, yeah. I know this was code on slides and maybe it was a bit hard to follow. So, basically, you don't need to remember all this stuff. If you just want to take a look at it, just go to this repository. There is an example app and also a template branch if you want to try it out in your own app. So just take a look at it. Yeah, that's it. Thanks for coming here today, and are there any questions?